All right, good morning. We are going to do objective 22 today. We are going to find the nth term of arithmetic sequences and sums of arithmetic series. Okay, so we're going to do two different things. First of all, when I'm saying the nth term, what am I referring to? I'm referring to whatever term you want to find. If I want to find the 50th term, then that could be the nth term. If I want to find the 22nd term, that could be your nth term. If I want to find the 112th term, that would be your term. My question is, how many of you, like if we know our common difference and we know what we're starting with, how many would want to draw 112 blanks to figure out the 112th term? And not many of us would want to do it. So therefore, we have a formula. And that's what we're going to be looking at today, is a formula to be able to find whatever term you're looking for in an arithmetic sequence. Okay. We're also going to look at sums of arithmetic series. So when I give you like the first 10 terms, the sum would be what you get when you add them all together. Okay. So those are the two things we are doing today. Here is your first formula. The nth term of an arithmetic sequence is a sub n equals a sub 1 plus the quantity of n minus 1 times d. This is on your formula sheet. I will give you a copy of the formula sheet tomorrow in class, so you can have that formula sheet from here on out on any test, on any classwork that I give you, and you'll get one on the SOL as well. So a sub n is going to be the value of the nth term. So if I'm looking for the 112th term, that's your a sub n. Okay, it's what is the actual nth term is, what the 112th term is. Okay, a sub 1 is going to be the value of your first term. And then d is going to be your common difference. Any questions? All right, so let's look at example 1. We are going to find the 12th term of the arithmetic sequence that starts with 9, 16, 23, and 30. So if I write my formula down, a sub n equals a sub 1 plus the quantity of n minus 1 times your common difference. My question is, we are looking for the 12th term. So that's going to make n 12. Okay, the nth term is whatever term you're looking for. So we're looking for the 12th term, so that makes n 12. So we are looking for a sub 12. And that's going to be the value of that term. Do I know my first term? First term is 9. Plus n, we're looking for the 12th term, so that's going to be 12 minus 1. And my common difference is plus 7. So don't forget, if you don't know what you're adding each time, you can take the second term and subtract the first term. So that's going to make my common difference 7. And then I can just work this out. So this is going to be 9 plus 11 times 7. Then you can put this all in your calculator. I'm going to multiply first and do 9 plus 77. So that means the value of the 12th term would be 86. Any questions on that? Okay. All right, so let's take a look at example 2. We know if we are looking for the nth term that we're going to use our a sub n formula. So a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference. So it gives us, and here's the concept, guys. In everything that we do over the next 3 days, here's our motto. Plug in what you know, solve for what you don't know, and use that to answer the question. Okay, so let's plug in what we know. We know that a sub 1, and that would be your first term, is negative 4. We know the common difference is 6. And we know we are looking for the 9th term because n is 9. So we are looking for a sub 9. So you can work this out. Now, remember, guys, that, you can always use your common sense brain. You need to understand that here's your first term, here's your second term, here's your third term, here's your fourth term. So if this is negative 4, and I know that my common difference is 6, that means I'm adding 6, what would be the second term? The second term would be 2. And then the third term, if I add 6 again, would be 8. And then my next term, if I add 6 again, would be 14. Okay? And you could sit there and you could draw out 9 blanks and you could find the ninth term that way. But once you get into finding larger terms that are well down in the sequence, you might want to use the formula. So let's work the formula out. So I'm going to do my parentheses first. So that's going to make 8 times 6. So negative 4 plus 48. Sorry, my board's not writing very well this morning. And so that's going to make my a sub 9, or my ninth term, the value of it, 44. Okay, so you go ahead and hit pause and see what you can do for this one. So if I use my formula, a sub n equals a sub 1 plus n minus 1 times the common difference. So I'm looking for a sub 20. I know my first term is 15. Do I know my n? Yes. My n, what term am I looking for? I'm looking for my 20th term, so that's going to make n 20. And then my common difference is negative 8. Again, you can put this all in your calculator, all in one big shebang. Or if you work by hand, you do your parentheses first. So that would be 19 times negative 8. And so 19 times negative 8 is negative 152. And then I'm going to add negative 15 to it. And so the value of my 20th term is going to be negative 167. Not 9, sorry, 167. So that's a sub 20. Okay. All right, so let's jump into what arithmetic means are. Arithmetic means are the terms between any two non-consecutive terms. If terms are consecutive, consecutive means they follow like one right after another. Like the third term and the fourth term are consecutive terms. The third term, the fourth term and the fifth term are consecutive terms. The fifth term and the sixth term are consecutive terms. But these are terms that are between non-consecutive terms. So like if I gave you the second term and I asked for the sixth term, or I gave you the sixth term and I asked you for the 3 terms, the third, the fourth, the fifth, that are in between those. So I've given you negative 8, and I've given you, that is your first term. So, and then we're looking here second, third, fourth, fifth, and I've given you your sixth term. So we're going to use our a sub n formula. And the issue is, like if I knew my common difference here, then I could fill in. That would be really nice. So we're going to plug in what we know. We're going to solve for what we don't know. Okay, so what do we know? We know the first term is negative 8. Okay. We don't know anything else other than my sixth term is 22. My question is, could I use that as my nth term? So could I say my sixth term, and the value of that sixth term, a sub 6, would be 22. I'm going to use that. So like these are like clues. So if they give them to you, you're going to have to use them. And so what I'm going to do is I'm going to solve for my common difference. So plug in what we knew. We knew the first term was negative 8, and we knew the sixth term was 22. So I used the sixth term as my nth term. So 22 equals negative 8 plus 5d. 6 minus 1 is 5, and 5 times d is 5d. And then I'm going to move this over and add 8. So 30 equals 5d. And then if I divide by 5, d comes out to equal 6. So I know that I'm adding 6 every time. So if I add 6, then I can just fill in my arithmetic means. So this would be negative 2, add 6 again. This would be 4, 10, 16, and then 22. Okay. So I want to find the 5 arithmetic means between negative 18 and 36. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 36. So this is your first term, second term, third term, fourth term, fifth term, sixth term, seventh term. Okay, so let's use our a sub n formula. Okay, plug in what we know. We know the first term is negative 18. The only other thing we know is we know the seventh term is 36. So let's use it. If they've given it to us, let's use it. Let's use that as our nth term. So that would make n what? It's going to make n 7 because it's our seventh term. And the value of it, that's your a sub n, a sub 7, is 36. Okay, and then I'm just going to solve for d. Plus 6d. So when I move this over and add 18, that's going to be 54 equals 6d. And if I divide by 6 on both sides, that's going to make d equal to 9. Sorry that my board's not writing very well today. And so if we add 9, that would be negative 9, because that's your common difference. If I add 9 again, that would be 0, then 9, then 18, then 27, then 36. So that works. Okay, let's move on. Let's talk about a series. A series is formed, and I want you to think, series sum. They both start with S. Series sum. They both start with S. Okay? It's when all the terms in the sequence are added together. What you get when you add all the terms of the sequence. An arithmetic series is the sum of an arithmetic. Sum of the terms of an arithmetic sequence. This should say sequence. Sorry for the typo. It should say sequence. I'll need to fix that. And a partial sum, here's the thing. What we are finding is we are finding a partial sum. The sum of the first 10 terms. The reason you're not finding a total sum is my question is, where do these sequences go? Like, could they go to infinity? Yeah, they could keep going. Like if you were adding 6, 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 you know, out the door, down the hill, up Main Street, circle the globe 3 times, all the way to infinity. So we're not finding the total sum because you couldn't do that because you would be going to infinity. Okay, it would never stop. But if I give you the first, if I give you a starting point and I give you a stopping point, I say here are the first 10 terms. What do you get when you add them together? And so that's why we call it a partial sum. Okay, because it's the sum of the first ever how many terms you want to say, the first 7 terms, the first 20 terms. So you're giving it an actual stopping point. So here's your formula. Again, this is on your formula sheet, and I will give you that formula sheet tomorrow. And it says S sub n equals n divided by 2 times the quantity of a sub 1 plus a sub n. Okay, and my question is do you understand what each of these things are? What is a sub 1? A sub 1 is your first term. Okay, What is a sub n? It's the value of the term you're talking about. Like if you're talking about the 10th term, then the value of that 10th term would be a sub n. That would make n 10. Okay? And S sub n is going to be what you get when you add it all together. It's going to be your sum. Okay? It's your sum. So let's look at example 6. The sum starting at 12, going all the way to 180. Okay? So let's look at our formula. It says S sub n equals n divided by 2 times a sub 1 plus a sub n. Okay? Now, let's plug in what we know. What do we know? We know our first term is 12. And we know we're going all the way to whatever this term is. So we know that that's 180. The issue is you don't know, this is your first term, this is your second term, this is your third term, dot, dot, dot. There are a whole bunch of terms before you get to 180. So my question is, what term is 180? We need to figure out what n is. So here's the thing. Let's use what we know. What else do we know? We know another formula. What other formula do we know? We know our a sub n formula. And my question is a sub 1 plus n minus 1 times a common difference. We know we're looking for the value or the actual number of what 180 is, what term that is. We know a sub 1 is 12. We don't know the n. Do we know our common difference? What's the common difference? What am I adding? I'm adding 7. So my question is could we use this formula to solve for n, and then once I know what n is, could I plug it back into the sum formula? And the answer is yes. So that's what I'm going to do. I'm actually going to solve this. We're going to distribute. I can't do what's on the inside this time because you don't know what n is. So you can actually solve it doing your parentheses first. So this will make 7n minus 7. I'm going to combine like terms. So 180 is equal to 5 plus 7n. I'm going to subtract 5. And 175 is equal to 7n. And so that's going to make n 25. So what does that mean? That means that 180 is the 25th term. Okay, so now I can go back in and plug in 25 for n. And now I can find the sum. So you can put this right in your calculator, or you can do it piece by piece. So this would be 192 oops, excuse me. Alright, so if we keep going with this, again, you can put this directly into your calculator if you wanted to. 25 divided by 2 times 192. And that is equal to 2,400. So what does 2,400 represent? That is the sum when I start adding 12 plus 19 plus 26 plus the 4th term plus the 5th term plus the 6th term all the way to the 25th term. What do I get when I add all those numbers together? And that is 2,400. This is called a series or a sum. When I say series, I'm talking about the sum. Okay? So here we go again. And if you want to hit pause and try this, you can. So we're looking for the sum. So my question is, like, when you get to the SOL and you want to know, like, what formula do I start with? Well, we're looking for a sum. So I would start with my S sub n formula. That's your series formula or your sum formula. So that's going to be n over 2 times a sub 1 plus a sub n. Okay, let's plug in what we know. We know the first term is 2. We know we're going to add it all the way to the 100th term. So that's going to be your a sub n term. My question is, we know this is the first term, this is the second term, this is the third term. Do you know what term 100 is? And some of you might know just because you know what you're counting by all the way to 100, but let's just assume you don't know. So if I don't know my n, we're going to have to go and use something else. So if you can't do it one way, let's see what we can do. Let's go back to our a sub n formula. Let's plug in my first term, which would be 2. I'm looking for my n, and we know the common difference is 2 because I'm adding 2 each time. And we know we're going to go all the way to 100. And we're going to just solve for n. So parentheses first, let's distribute 2n minus 2. So those cancel, and 2n is equal to 100. I'm going to divide by 2, so n is equal to 50. And that makes sense, because if you're starting at 2, and you're going to count by 2's all the way to 100, so how many? That would be the 50th term. So I'm going to go back and plug 50 in. And then we're just going to work this out. So this would be 25 times 102. And then 25 times 102 is equal to 2550. That is the sum, what you get when you add the first 50 terms from 2 to 100. Okay. So if it says find the sum, what are we looking for? We are looking for our S sub n formula. And let's plug in what we know. We know, in this case, n is 16. So we know we're going all the way from the first term to the 16th term. We know a sub n, so that would be the value of the 16th term, would be 240. My question is where do I put the common difference? And there's nowhere in here. What are we missing? In order to find this out, we need a sub 1. We need to figure out what the first term is. Okay? So what we need to do is we need to go back to our a sub n formula. I call this Old Faithful. Okay? We always revert back to Old Faithful. A sub 1 plus n minus 1 times a common d. So let's use, we know a sub n is 240. We're going to search for a sub 1 this time. We know our n is 16. We're going all the way to the 16th term, and our common difference is 8. So then I'm just going to solve this. 15 times 8. So 15 times 8 is 120. So a sub 1 is equal to 120. Okay? So we can go back and plug in 120 for our first term. Okay? So 16 divided by 2 would be 8 times 120 plus 240 would be 360. And again, you can put this all in your calculator all at once if you'd rather. So the sum is going to be 8 times 360, which is going to be 2,880. What you get when you start at 120 and you add every term, the first 16 terms, all the way to 240. Okay, so we two more things to do. We have example 9, example 10. So what I want to do is I want to write the first 3 terms when a sub 1 is 7, a sub n, we're going to go all the way to 79, and s sub n is 430. So basically, let's draw some blanks. Here's our first term, and we want the first 3 terms. So if I knew my common difference, this would not be an issue. So my question is which formula do I start with? And I would say, let's start with S sub n because I've been given the sum. So sorry. This would be n. N divided by 2 times a sub 1. Let's plug in what we know. Okay? So we know S sub n. We know the sum is 430. We know my first term is 7, and we know we're going all the way to 79. My question is, do you know n? No. So what we might want to do is we might want to solve for n. Okay? We might want to solve for n. So let's go ahead and add this together. 430 equals n over 2. That's going to be 86. And we can divide 86 by 2 if you wanted to and simplify and make that 43 in this one. So 430 is equal to 43n. And then I can divide by 43. Oops. There we go. Sorry about that. And so n is equal to 10. Okay, so we know n is 10. Well, that doesn't help me out right now because we're looking for the common difference. So where can I get the common difference from? So we've used this formula. We plug in what we knew. We solved for what we didn't know. N doesn't really help us. But maybe, let's go back to Old Faithful. Old Faithful is our a sub n formula. And again, these are the only two formulas that you have. So you kind of just plug into both of them and start finding things you need and then get what you need. So we know our a sub n is 79. We know our first term is 7. We know my n is 10. Oh, so that's where we're going to use the n. So you had to use this first formula to find n times the common difference. And then I'm going to subtract 7. So 72 is equal to 9d. And I'm going to divide by 9. So that means my common difference, d, is equal to 8. Okay, so now if I know that I'm adding 8 every time, this would be 15, and this would be 22. So that's our first 3 terms. Okay, so again, here's the concept. Plug in what you know. Solve for what you don't know. And then just keep plugging in till you get what you need to answer the question. Okay, and you got your 2 formulas here. There's not going to be any other formulas for arithmetic. These are the 2 formulas that we use. So just work between both of them to get what you need. Okay? All right, so last one. So I want the first 3 terms. So 1, 2, 3. And I would draw blanks. That helps. We know our first term is negative 24. We need to find the others. So let's start with our S sub n. And if you want to hit pause and try this, that would be great. So S sub n is equal to n over 2 times a sub 1 plus a sub n. Okay? So we know a sub 1 is negative 24. We know a sub n is 288. We don't know the n. We don't know what number term that is. We know we're going all the way to 288, but we don't know if that's our 5th term, our 10th term, our 15th term. You don't know what that is. We know the sum, though, when you add it all together, is 5,280. So let's go ahead and solve for n, because we're probably going to need that to use in the other formula. So 288 minus 24 is 264. And then if you wanted to, you could take this and simplify it and divide it by 2. So 264 divided by 2 is 132. 5280. So 5280 is 132n. So I'm going to divide by 132. So 5280 divided by 132 is 40. So n is equal to 40. So we know we're going all the way to the 40th term. So n is 40. All right. Now, if we knew our common difference, we could answer our question. So let's go back to Old Faithful. A sub n is equal to a sub 1 plus n minus 1 times common difference. So let's plug in what we know. We know a sub n is 288. We know a sub 1 is negative 24. We know n now is 40. So we know our 40th term is 288. N is 40, a sub n would be 288. Let's solve for our d. Let's find our common difference. Plus 39d. So 288 plus 24, because I'm going to move this over and add 24, is 312. And then I'm going to divide by 39. So d is 8. So there's your common difference. So if I add 8, that would be negative 16. If I added 8 again, that would be negative 8. So there is your first three terms for that sequence. Okay?